Greetings and welcome to the Introduction to Astronomy. In this week's Astronomy of Other Cultures, we are going to continue our look through the astronomy of the Muslim world and talk about Nasir al-Din al-Tusi and his contributions to astronomy. So let's go ahead and get started. So this is Nasir al-Din al-Tusi, who lived from 1201 to 1274 and worked on astronomy and other sciences in Persia. Now we're going to focus specifically on his contributions to astronomy here. And one of the things that he did was to push for the construction of a new observatory. So the whole idea was to get more accurate observations, to make more accurate tables of planetary motion. The better we could get the exact positions of the planets, the better we'd be able to make the models work. And in fact, he wrote the Ziji il-Kahani, that was a book for calculating positions. And that was a way to calculate the positions in the sky. Now, again, as we've looked at, one of the big problems that astronomers of this era had with Ptolemy, and Ptolemy's work in the Almagest was the definitive work up to this point. But one of the things that bothered a lot of astronomers was the fact that you had to use things that were not physical, like an equant or the epicycle that we've looked at previously. And al-Tusi came up with what is now known as the Tusi couple, which is a way to create linear motion from two independent circular motions. So you can have something moving on two circles, but its net motion will be a straight line. And we can look at an example of that here in this diagram, and we can see that as the two circles are moving, as one object is moving around, the blue object moves around the outer circle, but stays attached at the point where the inner circle meets it. And the green object is on the other circle, is that you can then replicate a linear motion from these two circular motions. If you watch how that green dot is moving, it is simply moving from left to right. But we can see that it's moving on two circles at the same time. So by putting these circular motions together, he was able to eliminate the equant, and one of the things that really bothered people about Ptolemy's work. So using that equant and getting rid of that was a big step ahead. Now again, that was still looking at everything as being centered on Earth. We haven't gotten past that yet. We are still focused on Earth-centered. And one of the other things that al-Tusi did was look at the Milky Way. Well, he didn't have telescopes, so he couldn't see directly what it was, but he wrote that the Milky Way was made up of stars, so that it was not just a cloud in the sky, but was actually made up of the combined light of many, many stars. This was later confirmed by Galileo. So when Galileo was able to turn his telescope to the Milky Way, he was able to see that, yes, it is indeed made up of stars. Al-Tusi was able to predict this hundreds of years before Galileo. And it is possible that a lot of his work influenced Copernicus later on as the work made it toward the back into Europe during the Renaissance time. So let's go ahead and finish up what we've looked at here with our summary. And what we've seen is that Nasir al-Din al-Tusi lived from 1201 to 1274, known for work in astronomy in Persia, and developed a model which may have influenced Copernicus centuries later. So that concludes this discussion of Nasir al-Din al-Tusi. We'll be back again next week to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.